luck. How many values do you?
Hello? Oh, no. No, no, no. No. No.
Okay. Hello, everyone. Here's the last free poster, if you want somebody, and his stickers, also free, if somebody want. Well, now please welcome Siddharth.
Thank you. So I'm Siddharth Sharma, and I work for the Red Hat product security team. Yep. Now? Yeah, it's much louder. Okay. So I work for the Red Hat product security team, It's again gone. Let's check here. Is it audible now? Yeah? Okay. So title of my talk is Tactics of Code Auditor, and it's about the code auditing is something which cannot be really taught. It's by time. It's like how much time you devote in reading code and doing stuff with it. So I'm going to share some of my experiences that I've been auditing code for past 2 years now, and so that's what I'm going to share, how I do it. And I don't say it's like the complete thing. People can actually implement on like their own techniques and stuff. So here is the agenda for the talk, and I'm not going to talk about it, just we'll go with that. So what does code auditing look like? It's actually the fourth in India. It's pretty amazing. If you see, this fort was built quite long time back, and the fun part with this fort is when the tides are high, this fort is like the water will be here, and you cannot go walking. You go through boats or any other means that works on that moves on the water. And when there is a low tide, you go by horses or the other means of the transport. So what I want to say here is it's like the source code or the application is same like this. If you put your application into different environments, it would have different type of vulnerabilities. It can be attacked differently at like the architectures, the way the application is running at the moment. So yes, it's pretty much the same thing. You have a backdoor in the fort. You have known flaws. You have unknown flaws. There are guards which you want to tackle them. So the scope of the audit, it's like many developers, or like I work for the team where we have customers who are internal to the Red Hat. Sometimes we get like the customers who use Red Hat products. They say, we want to buy this product, but what's the proactive effort that you are putting it into the code audit or of the application? Many developers would ask, okay, we have implemented this feature in the application, and we want someone to look at it. Like there might be some vulnerability, or not in terms of the open source or the Red Hat, but like people who are the freelancers, they can go for the bug bounties and 0 days. We all see that. A lot of times, like the program managers of the product or different people involving the product, they will say, okay, even if you find the low or the moderate vulnerabilities in the code, just tell us, we'll fix it. So when you start auditing code, it's really important to understand like what you are looking for. There might be like your customer wants only the vulnerabilities, those are critical or important to them, and they just don't care about like the lows and moderates, so you don't report them. So this is pretty much the methodology that I use. It's when you are looking for the particular application, you should really look at the documentation, exactly the same version of the documentation, which applies to the source you are auditing, because that's really important. And most of the times in the documentation, you are going to see like comments, or even in the code, you can see the comments from the developers saying that, okay, we have not implemented this feature, but this is really important. And then you know where to look at. The other thing is I haven't tried it because most of the developers like live outside, or like I don't talk to them in the real world. It's like you talk to developers. When developer is really drinking, you should go and ask them. They might spill the beans, like they have this problem in their code, and you would know, yeah, this is something which we need to look at. The other thing is, if the source code that if the application you are going to audit, it has been in the community for a long time, you should see like what the other like the people in the community are saying about it. They might have some ideas. Okay, we think this could be the security flaw in this application, but no one knows it. So you have some idea, like some boundaries where you can start thinking of it. There is an idea, and then you start developing the thing that, yeah, how you are going to audit that. The other important part is, if there is an application, you should really know there could be like million lines of code in it. So you should, if you are able to get the blueprints of the application, like how it works, like what is the architectural design of the application, you might not want to look at the backend, like whatever it's getting stored in the database, but rather the modules or the other places in the program where the user is getting feeding the input to the application. So you can literally cut down the areas where the places where you are going to see or look through the code, because in no way you are going to like people can audit 1 million lines of code or like larger than that in a week or 2 weeks. It's not possible. So this is like, I'm just taking example of the Ceph. Like this is the architecture, how it works, what's there. So you get some idea like how you want to audit the code, where are the places where you want to look. For example, if there is some network thing, or maybe at the places where the cryptography is used, or the places where there should be the like really secure channel in the data, and the developers have not implemented it. So those are the good places to look at in the code to find out the vulnerabilities. Yeah. Yes. So, like, why the application was written, who are its users. It's also really important, because if there is any daemon that is going to run as a root, and there is no, like, not much users, but it's a daemon, then you see things like if daemon escalates privileges like get UID or set UID, and there are places in the code where it doesn't drops it properly. So you might want to look at those places in the code as well. So basically, you should have some high-level view of the application, where you can think in the boundaries where an attacker would be looking at. Yes. Like authentication, information disclosures while logging data. So this is also really important. For example, a lot of places in the application where developers enable the debugging logs, and the debugging logs get shared with the other people, or they might load it to any public places that can have password, IPs, a lot of places. So this is also one of the important parts for the information disclosure, like how the application is logging data, especially the debugging logs. And the crypto failures, yes. Also, just not by looking at the source code, but it's also important when you compile source code. Compiler will throw up a lot of warnings. Like when we build the RPM packages, you can see the RPM build logs. What's gone wrong over there? It might So there's some places where the code was not properly written. So you get some ideas about the application or the code. So I'm basically going to talk about the C and C++ vulnerabilities here, like the common type of vulnerabilities in the code where people can actually see them. So the first one is the buffer overflow, then the data types, and the miscalculation or the bad logic that happens in the code. Predictable file names. For example, in the terms of the buffer overflows, these are caused by the bad APIs. You can see memcopy and strcopy and things like that. You can just in such situations, what I usually do is I just grep these functions, just throw them at the source code, and if there is something that it shows over there, I don't have to use like a lot of tools, different tools to do that. So if you see these things, you can just directly just log them into your audit report and say, okay, this needs some change. But usually these are not really very critical vulnerabilities nowadays. Yes. The other thing is, long time back, if the code is using any string functions and you don't import the string.h, there are completely lot of security checks that those miss in the code. So while compiling also, for example, the 45 source will not work. It will not have the proper security checks, and if you have a overflow or any format string attack over there, it's just maybe the application just won't crash, and you will get an overflow over there. Also, it is important while compiling the code, you use the D45 source with the optimization flag, because if you don't use the optimization, then also just 45 source doesn't work. But in our RPM builds, we make sure that that's enabled by default. So in terms of the like buffer overflow, it's the classic buffer overflow that happens all the time in the code. If you can see, there is a argument that goes directly into the sprintf, and you can actually see a lot of places in the code where the user data directly gets into these functions. So these are one of the places where you should look at, like from where the source is coming and from like what is the source and where it is writing to. These are also some of the examples that you will find in it, find in the code. For example, sometimes developer doesn't thinks about the null termination of the string, so you get an off by 1 byte error, and below is the code how you fix it. Like you calculate the string length is not greater than the buffer -1. That is for the like you calculate the null string at the end, and that's how you return it. But basically, those are places where like you can look in the code for the overflows. So the next are the data type flaws. These are different on the different architectures you are working on. For example, the x86 or ARM or any other architecture, it would be different because the data type handling or the size of the data type would be different. So integer overflows are associated with it. It's like signed and unsigned data types, which have like major problems in that. You will see a lot of places developer uses size t and size t. So size t is like the unsigned data type, and size t is the signed data type. Now, how many people know here like how the signed and unsigned? Is there anyone who doesn't know that? Okay. Like what is the difference between the signed and the unsigned data type? Like everyone knows here, right? Yeah. So there are a lot of places like the SIST signed data type is not said to be used, but there are actually some of the places where you will find like developers do this common mistake. And you can see in this code, it uses SIST, and then this is the user data and the length that goes into some check, and that returns -1. Now that goes into the size, and what happens is it's returning -1, but this is the unsigned type. So it's going to wrap, and this there will be very large value that's going to be stored in the size. And this statement will always be false, so it won't hit here. Though there was a security check done, it returned -1 on error, but here it's never going to check because it just wrapped, and now the size has the positive value. And it will escape this code, and then you have like, boom, 4 gigs of memory allocation. So that's how like it's 2's complement how things work. That's 32-bit. Signed, it's like the first bit is used for to store like negative values or what. But so this is the common problem. Like you use the unsigned value, and the maximum value it can store is like 255, and in some logic it adds 1 to it. Now it will be like 0. Now the overflow bit in the processor is set, but it's checked nowhere. So it's pretty much common mistake in the code that happens. The same applies to the signed variable also. If you add 1 to it, it becomes -128. This is also bad code. Can anyone tell me like what's the problem in this code? Yep, you get a muffler. So should I give it now? It's here. So, yep. There is some more bad code. Anyone? This one was actually, yeah, I can actually show you. This is from one of the CVs that we have. To actually hear what the problem is. it's, yeah, I don't know why it's so bad, but okay. I can. So basically, what it's expecting, it's a the function is expecting the 4 digits, but what happens is as soon as the PID goes up 1, there is an overflow, and that becomes this FFF here. After this operation, it becomes 10000, and it overflows. So, like these are pretty common errors that you can look in the code. Now, a lot of places, this is actually from the Python code, but yeah, a lot of Python or yeah. A lot of places in C, C++ programs, and maybe it would be relevant to any other program also, that they are writing to the temp directories. Now, if there is a daemon which is working and using the temp directories, and attacker has access to it, they can actually use they can just swap it with the malicious code over there, and whenever the daemon again reads, and it's going to execute, and you get pretty much root. If it's daemon, it's working, it's on the root privileges, you will get it. The other thing is, sometimes it doesn't depend mostly on the source code, but how it is shipped to the customers, because, for example, when you create RPMs or just the mechanism like to deliver these updates to customer, it also depends on the way you have packaged it. So, for example, if there is a post-install script which is using this, that's bad. It also happens in the spec file. So you just leave the boundaries of the source code as well. The code auditor, as in, like, has to take care about things how this is going to be delivered to the customer as well later. Because suppose if this is an RPM and you are like internal user, you can just wait and you'll know when your admin is going to update the RPM. You can just change this. You can add sudo, your name, and RPM uses the root privileges to install on the system. So whenever RPM is going to install and do the post-install script, done. About the tools, source code browser, yeah, everyone uses it. I use cscope just to see some of the functions, how they are getting called to and fro. Because if you are running some of the static analyzers, they will say, this is the function that you need to look at. But then you go into the function and you see like how the values are coming from the other function to this function, or how the input is coming to this function. So I just use like cscope or some other tools to see how the functions are getting called from the start of the main function. So you actually backtrack. You have a place that static analyzer showed you. Then you backtrack to the place and see how things got manipulated in between, or if they can be. So some of the fast things are like you can use CPP lint or FLAW finder or CPP check. CPP check is good. It shows quite a lot of problems. And there is this post memory corruption memory analyzer. It's on the GitHub. If anyone wants, I'll share the link. You can pretty much run the program and attach the PID to this. So whenever the program is going to crash, it is going to analyze it automatically and will tell you most of the areas or the regions where things were executable on the stack or the heap or wherever. The other part are like the sanitizer. So this is also important in terms of the code audit because developer, like the code auditor can spend a lot of time reading the source code, and it gets frustrating not to find anything over there. So what I usually do is I just compile the source code with the address sanitizers, and I just run them. And whenever there is some corruption or anything, it just tells where exactly the corruption happened, and you can just go back and fire up your source browser, and then you can look at the code where it happened. So it's, for me, like code auditing is not only like one way, it's from the other way as well. Yeah. And then there are fuzzers, but that is like pretty much the pen testing that people do. But yes, as a code auditor, if you can do that, it's good. It helps you track down the places which might have been left in the code audit. So about the sanitizers, there is this libasan. If you are using Fedora, you can just install libasan, and it works with the GCC. You can just compile it with fsanitize equal to address flag, and it will set it. So address sanitizer can pretty much find these use after free, double free, buffer overflows, and such type of flaws. And there is another library in the Fedora called libtsan. You can just put flag fsanitize minus fsanitize equal to thread. Then the thread analyzer will come into the picture, and it checks for the race conditions and the deadlocks. So these are good. About msan, I don't think so there is a package available in Fedora, and so just tracks for the uninitialized memory spaces. So also, as a code auditor, you like we use CVSS2 in the product security also at the moment for analysis of the flaws. But as a code auditor, you can use these things to actually identify the impact of the vulnerability or you have found. Like XS vector, it's how you are able to get into the program. It's based. It's a local. It's on the local machine or the adjacent network, like on the VPN or the intranet, or it's some kind of a daemon that you are able to access through network. So you just use these values, and there is a CVSS2 calculator which will show you the impact of that. So this is pretty much. Anyone has any questions? Yeah.
Looks like most of the bugs that you showed, at least the ones with the signed, unsigned switches, would have been found by the compiler in the right warnings.
Yeah. So yes.
So when you find something like this, do you also try to change the way the project is built so that If you do that, you're getting pushback. It's very simple to convince people that they should turn on these warnings.
Actually, like I have not dealt with most of the developers like that. Just we say like this is the flaw, that's it. But nothing like that. But yes, the same thing is if you see the build logs of any project, the compiler would be able to show that. But the most important thing is if these are built on a system where no one is looking how it's building, it's going to miss it.
Well, then you can treat warnings as errors, right? That's also pretty.
Sorry?
Well, treating errors like
Yeah.
treating warnings as errors is pretty reasonable.
Yep. Yes, it should be.
Kind of like the goal of everybody's job should be like our job should be to automate ourselves out of our jobs, right? So I'm wondering if you just try to look for these things and fix them one by one, or if you have like higher level agenda.
Yeah. So there are like some of the things I showed you some of the like the classic things or the functions. What if so when we say don't use band API to a developer, then developer can actually write his own band API at some point, like not to use those functions and do something like that, and then compiler won't show any warnings like that. Like for example, the string copy or any which were like band APIs. A lot of people might write their own C code just to do that, which is like more bad. Now, the job of the auditor has become more difficult because now tools are not showing that. Any more questions?
How much time do you spend on, and how big amounts can you audit?
I usually spend my Fridays on it. Yeah, because
Actually, not to contract you talk, but I read a thing once years and years ago, back when I worked with computations. They say that after an auditor is working for like 2 hours on a piece of code, they almost never find anything after that.
yeah, it's actually you should know when to leave, when to give up on something, and then maybe it's not your day in front of the code that you are auditing. Maybe the next day you might come, huh?
It's just like playing along.
Yeah, because it's really frustrating. It's not something you know beforehand, like your manager or anyone will not come to you and say, you have to find 100 flaws in this source code, now find it. Maybe there is nothing, maybe it can also skip the eyes of the auditor, and that's why there is more usage of things like the address sanitizers and the things which missed the audit. But again, then auditor can go back and see things like what were the problems, and then go back and look at the code again.
How much do you use community?
Like a lot of, I guess, I don't know about that. A lot of RPM packages have, they use Coverity, but I basically don't use that much. For me, yeah, static analyzers are good, but there are a lot of false positives in the static analyzers, and if it is going to give you like 4,000 places in a million lines of code to check, it's completely not possible. So the only way is like you run the application, you poke it several ways, you see where the crash was, and then you try to match where the static analyzer said it was important, and then you can see some link between those two places. Then you know exactly where to look at. It's like in auditing, you cannot start from the main function, right? Int main, and then you start from where it is coming. It's long way.
How often do you actually use fuzzers?
Fuzzers I use very rarely, very rarely, because fuzzing is completely different world, and there are like lots of fuzzers. Today, if you go and see, there are lots of fuzzers, and yes, it's a bit difficult, but I usually do the classic ways of exploiting. I usually use my classic ways of exploiting that used to be done before the fuzzers were there. Just send some crap into the system and see where it crashes. But that's what fuzzer does it for you, like doing the permutation and combination of different type of things. But yeah, sometimes it's a bit difficult to use fuzzer in some projects.
Another question. So when you use fuzzers, probably you do it with particularly important projects, right? You don't do it for every single code review you need to review, right?
Yeah. No.
So do you have any criteria with which you select projects that are fuzzable?
So, for example, I work particularly in storage. I look at the storage security for the Ceph and the cluster. And for me, the important areas are there. But there's like vast number of people working on like different products. So they will have different type of approaches to their own products. For me, it's for the storage only. Yeah. Done. Yeah. Thank you. That's. Oh, I guess no one wants this. So mufflers are here. You can take it.
May I have a question? My question is pretty silly.
Yeah.
Because I'm pretty new to
No.
First of all, because I was, when I was learning programming, usually you have to name variables and files which with names that is recognizable. But you offered to name files in an unpredictable way.
Yes.
Why?
It's because okay.
Okay, sorry.
If you have a predictable file name, and those are writable by its program, then you can just write anything to that file. Because you know what will be the temp file name. So even the file is not predictable, but I can go and get that file because Dagger already knows this will be the name of the file and program will run and create it. So you create it, and then if suppose it's running any bash script or anything, you can just sudo yourself in the script because the daemon or the program will run with its privileges. And then it will execute that code what you have put in the temp file.
Okay, makes sense.
And then you can get root on the system.
Yeah, and one more question because I'm really don't know a lot about security. What would you recommend to start with some basics about security, coding, some literature? Yeah, sure. I'm sorry.
I saw you didn't mention Valgrind, so the ASN, ASAN is like this similar, maybe better?
So with the Valgrind, the problem is because that's a runtime thing, and the application becomes really slow.
So sometimes it affects it?
But yes, it does find a lot of flaws like memory-based flaws. But in terms of the address sanitizer, it's like it's at the compile time. It just puts the check at the compile time.
No, but still you have to run it, no? With the ASAN.
You just compile it with the ASAN, and then
Run it with the ASAN, no?
Yes.
Just compile it and run it.
Yes. So that's it.
So,
Presentation.
Oh, okay. Okay.
thank you.
I had demos too, so but there was not. I'm sorry, just give me
Yeah,
this.
sure.
Just give me
Okay. Do you have one? Do you want to have a Mandarin? I have. I have with me. Oh,
Thank you very much. There was a folder, right?
Yeah. Thank you so much.
or maybe you can give me email. I will write you
You work at
for
Red Hat?
request. Huh?
You work at Red Hat or?
No, I don't work on Red Hat.
Okay.
I will request for literature because I started to. I was interested. I started with some kind of very serious book, and it was
The
like
same. My name and Siddharth.
Siddharth.
Yes.
Is it S? Siddharth.
Yeah.
Okay, it's D.
I'll
All right. Okay. So I will write it to you right now. Thank
okay,
you.
okay.